I hope this is recording. We'll find out. So this is the beginning of a unit on motion graphing, which we've done with the motion detectors, but the graphing was done automatically. Sometimes we don't use motion detectors, and we have to graph the data ourselves by hand, and we can learn a lot from doing that, surprisingly. At least I think so. You'll let me know what you think. There's three different kinds of graphs that we're going to be looking at. We'll start with the easiest one first, like we did with the motion detectors. We'll start with the position versus time graphs first. So I'll make an example of a position versus time graph. That might be a y-axis. That might be an x-axis, like that. Is this clear enough for you guys to see, or do I need it to be darker? Okay, so let's say this is time, and this is position on the y-axis. Maybe position is in meters, and time might be in seconds, because that's a pretty common unit for time. And maybe this would be 0 meters, this might be 5, 10, 15, this might be -5, -10, -15, something like that. And in terms of seconds, maybe this might be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, kind of like that. How are we doing so far? Okay. All right. So maybe I stay right where I am to begin with, right at 0. And I hang out there, and I hang out there for 3 seconds. And then I start to move like this. To here. So that would be what, 6, 7, at 8 seconds, I'm whoops, here. Oh, what the heck? Let's go to 9 seconds. Right there, right to the top 15. And then I come all the way back, like that. That's a pretty simple looking graph, right?
Yeah. All along that time it goes up.
Yeah, they're every little, every.
Yeah. Okay, I was maybe.
You're right. No, you're right. So there's two properties of a graph that we're going to be looking at over and over and over again. One is the slope of the graph, and the other one is the area underneath it. So the area underneath it, might be, say, this stuff. The area in there. This would be area. Is that right? Okay. And slope is, well, it's how steep a line is. You probably remember from algebra, slope is defined to be the change in the y over the change in the x. Remember that?
Yeah.
And so the y variable this time is position. That might be in meters. The y variable is meters. And what's the x variable? Seconds. Yeah, seconds. So that's going to be my speed, actually. Meters per second. That's units of speed. How fast. So for the first 3 seconds, what's my slope here?
Constant.
Well, yes, it is constant. And constant at what value? How much is my change in y variable?
0.
0 meters, and it took 3 seconds, so that's of course still 0 when you divide. 0 divided by 3 or any other number is still 0. So that's a slope of 0, which means I'm stopped. The slope of this graph is my speed, remember? So for the first 3 seconds, what we basically learned is I'm stopped. But for the next time interval, from 3 to 9, for the next 6 seconds, I'm definitely not stopped. I've gone from nowhere to how far away?
10. 15. 15.
Okay, no need to guess, just look at the graph.
That's at 15.
How far away am I? I'm 15 meters, and it took me 9 seconds to go 15 meters. No, 6 seconds, right? 6 seconds? From 3 to 9 is 6 seconds? In these next 6 seconds, I went 15 meters. So that tells me that my speed here, my slope, or speed, is change in meters divided by the change in time. 15 minus 0 meters over 9 minus 3 seconds. Or to put it another way, my speed is 15 meters in 6 seconds, or 2.5 meters per second. During this time interval, which I'd like to color in another color so you can see it better. During this time interval of 6 seconds, my slope is definitely not 0. It's 2.5 meters per second. I'm going to zoom out just a little bit so you can see it better. How's that? Okay. Anybody have a question at this time? Anything at all?
Yeah, it's like not focused on that.
Oh, see if we can do that.
There you go.
That was a good thing to get, right? Are there any other questions? Yeah. Ashley, and then, I'm sorry, one. The delta? That a triangle, that's a good question. A triangle is strangely enough, is a letter in the Greek alphabet, and it's called delta. That's how you pronounce it. In Greek, you would call it delta. And it means, as a mathematical symbol, it means change. The change in whatever it is that comes next. So the change in position is how far you go, and the change in time is how long the time goes by. So this is clearly a positive slope. I'm going farther and farther away from home. And then I come back home. That's going to be a different kind of motion. It's going the other way. If one's positive, the other one can't be positive too. It has to be the opposite of positive.
Negative.
It has to be negative. So I'm going to try to make that plain as well. So this slope over here in blue is another value. Let's just look at it. What is my slope there? And I think I'm going to blow it up again so we can see it in more detail. How are we doing? Okay, so my change in position is going from here to here. Is that a positive or a negative change, going from here to here?
Negative.
Yeah, it's going to 0 from 15 meters away. That's a change of negative 15 meters. 15 meters closer than where I was, not farther. And the time interval is from 9 to 10 seconds. So that's 1 second. 1 second. And so apparently my speed is different. It's minus 15 meters per second, way faster. Way faster than the 2.5 that I was doing when I was going away. Kind of slowly. Much steeper slope here going down than there was going away.
So I have a question. Yes.
Please, ask it.
So the orange part is the slope, like how like when it starts increasing.
That was just the first, that was when I started to move at 3 seconds right here, and I started to move, and I moved all the way out to 15 meters. In the next 6 seconds, I must have been moving at 2.5 meters per second. 2.5 meters, then 5, then 7.5, then 9, then 11.5, then whatever, up to 15.
Okay, so like when we're doing the velocity and like that thing with the motion thing, you know how like we have like I think like last week how we had the thing at the end and we would walk back and forth.
Yes.
And then on the
So the orange part would be like when you were walking away from the
it
detector.
would like go up.
Yes, and this would be coming back. Only it looks like you came back a lot quicker than you walked away. So far, so good?
Yes.
Okay. That's excellent. Now, it turns out that the area in here, on this particular kind of graph, doesn't mean anything. I mean, if you were to multiply to get the area, the height times the base, meters times seconds, does a meter second mean something to you guys? Not to me either. So we can ignore area for now on this kind of graph. On the next kind of graph, though, we can. So in general, we'll need to look at area, but not this time. Say it once again, Ashley.
Why did you look at areas like this?
Because if you look at area, yeah, because it's a position graph. If you look at the area units, they would be whatever the height times the base units are, meters times seconds. And what's a meter second? No, there isn't anything that's a meter second. Has no physical meaning. So I'm just going to draw a line here and say that that is the end of our first kind of graph instruction. That's the end of the first one. And in order to make life a little easier for you guys, I think I'm going to end this video. And if we start another one and finish it, that's cool.